1. When the universe isn't so far away, while most people remain absorbed in their daily lives, few realize that our Earth is moving through a space filled with hidden dangers. Among them are asteroids, massive chunks of rock and metal silently hurtling past our planet at tens of thousands of kilometers per hour. Though they may seem like something out of science fiction, meteorite impacts are real events in Earth's history and could very well happen again. Thanks to advancements in space technology and astronomy, humanity is gradually gaining a clearer understanding of these threats, and is beginning to develop plans to defend against them. Would you like this translated into another language or adjusted for a specific audience? 2. What are asteroids and why are they dangerous? Detailed. Asteroids are small, solid celestial bodies that originated during the early formation of the solar system, more than 4.5 billion years ago. They are remnants of the material left over after the formation of larger planets, essentially the debris from the planet-building process. Asteroids are primarily composed of rock, metal, such as iron and nickel, or a combination of both, and they vary greatly in size, from small rocks just a few meters wide to massive objects hundreds of kilometers across. Most asteroids are located within the asteroid belt, a vast region of space between the orbits of Mars and Jupiter. This area contains millions of asteroids, but thanks to Jupiter's immense gravitational pull, the majority of them are kept stable and pose no threat to Earth. However, many asteroids exist outside this zone, especially those with irregular orbits that have been altered by gravitational forces or collisions in space. Some of these objects have orbits that cross or come close to Earth's path. These are known as near-Earth objects, NEAs. NEAs pose the greatest threat to our planet. They travel at extremely high speeds, typically ranging from 20,000 to 70,000 kilometers h, about 5 to 20 kilometers s. At such velocities, even an asteroid only tens of meters in diameter could unleash an explosion equivalent to tens of megatons of TNT, many times more powerful than the atomic bombs used during wartime. If the asteroid were hundreds of meters wide or more, the consequences would be far more severe, potentially causing not only regional devastation, but also global climate disruptions and threats to life on Earth. Another alarming aspect is our limited ability to detect them early. Smaller asteroids can easily be obscured by sunlight, move too quickly, or have dark surfaces that don't reflect enough light for telescopes to detect them. Many asteroids are discovered only days, or even hours, before passing close to Earth, raising concerns that an unknown object could strike suddenly, with little to no warning for humanity. Additionally, while Earth's thick atmosphere can incinerate most small space debris before it hits the ground, not all asteroids are stopped. Objects with diameters over 30 to 50 meters can still penetrate the atmosphere and explode mid-air with tremendous force, generating shockwaves capable of destroying infrastructure, flattening forests, and causing heavy casualties if they strike populated areas. In short, asteroids are dangerous for three main reasons. 1. They travel at incredible speeds and carry immense impact energy. 2. Their orbits can shift unpredictably due to gravitational forces or collisions. And 3. Early detection remains limited, making defense efforts extremely challenging. For these reasons, studying, monitoring, and developing defense strategies for NEAs has become one of the top priorities in global space science. Would you like this adapted for a younger audience or used in a specific format like a script or infographic? 3. Impact events that shaped Earth's history. Earth has experienced numerous collisions with celestial objects from space. These events not only caused local devastation but, in some cases, completely altered the course of life's history. One of the clearest examples is the Chicxulub impact, which occurred around 66 million years ago. When an asteroid measuring between 10 and 15 kilometers in diameter struck the Yucatan Peninsula, in present-day Mexico, it triggered an explosion with energy billions of times greater than the atomic bomb dropped on Hiroshima. The enormous cloud of dust it raised enveloped the Earth, blocking sunlight and triggering a phenomenon known as the asteroid winter. The resulting collapse of ecosystems led to a mass extinction event, including the disappearance of the dinosaurs. A more recent and equally alarming example is the Tunguska event of 1908 in Siberia, Russia. A meteoroid about 50–60 meters wide exploded in the atmosphere, generating a shock wave that flattened over 2,000 square kilometers of forest, an area twice the size of New York City. Notably, had the explosion occurred over a densely populated city, the death toll could have reached hundreds of thousands. The Chelyabinsk event in 2013 further underscored this threat, when a small meteoroid exploded in the sky, injuring over 1,000 people due to shattered windows and flying debris. Would you like me to continue translating the next section or help format this for educational content or a presentation? 4. Asteroids under close surveillance. Today, with the aid of remote sensing technology, space radar, and advanced telescope systems, scientists have identified and are closely monitoring tens of thousands of near-Earth objects, NEAs. Some of these are classified as potentially hazardous asteroids, asteroids larger than 140 meters in diameter whose orbits cross Earth and come close enough to warrant concern. One notable asteroid is Apophis, which measures about 370 meters in diameter and was once predicted to have a potential impact risk with Earth in 2029 and 2036. Although the probability has since been revised to near zero, the event attracted global attention. Another example is asteroid Bennu, the target of a NASA research mission, which is predicted to have a small chance of colliding with Earth in the late 22nd century. These cases serve as stark reminders that the threat does not come from deep space, but from objects orbiting the Sun alongside us. 5. What would happen if a large asteroid hit Earth? The consequences of an asteroid impact depend not only on the object's size, but also on its velocity, angle of impact, and location of collision. An asteroid roughly 1 kilometer in diameter could unleash an explosion equivalent to millions of megatons of energy. The shock wave would obliterate everything within hundreds of kilometers, triggering wildfires, tsunamis, if it strikes the ocean, earthquakes, and global climate disruption. The resulting dust and gases could spread across the planet, altering weather patterns, reducing sunlight, collapsing food chains, and causing ecological crises. Simulation models show that even an asteroid just a few hundred meters wide could cause millions of casualties if it struck a densely populated area. A much larger object, over 10 kilometers in diameter, could bring about doomsday-level destruction, similar to the impact believed to have wiped out the dinosaurs. To confront the threat of asteroids and cosmic collisions, humanity turns to science and technology. To face the threat posed by asteroids and cosmic impacts, humanity is placing its hopes in the power of science and technology. In recent years, major space agencies such as NASA, ESA, European Space Agency, and JAXA, Japan have launched programs to track and provide early warnings about near-Earth objects, NEAs. Thousands of asteroids are being monitored daily through advanced telescopes and cutting-edge radar systems. Notably, NASA's DART mission marked a historic milestone by intentionally altering the course of an asteroid for the first time, opening the door to future planetary defense strategies. At the same time, Scientists are researching even more advanced technologies such as high-energy lasers, gravitational tractor spacecraft, and directional explosive devices to deflect hazardous space objects before they get close to Earth. These efforts reflect not only human ingenuity and ambition, but also highlight a vital message: life on Earth depends on proactive, global collaboration to protect our planet. In the future, international cooperation and investment in space technology will be key to ensuring that humanity is not caught off guard by cosmic threats, dangers that may seem distant but could become real at any moment. The threats from asteroids and cosmic collisions may not occur frequently, but their potential consequences should never be underestimated. Life on Earth has been affected by cosmic catastrophes in the past, and it could happen again if we are not prepared. Fortunately, with remarkable advances in science and technology, humanity now has more tools than ever to detect, monitor, and even intervene to prevent collisions from space. But above all, what's truly essential is awareness, understanding, and support from each individual for space research and raising public consciousness. If you find this topic fascinating and want to explore more incredible stories about the universe, science, and astronomical phenomena, subscribe to our YouTube channel today. Don't forget to like, share, and turn on the notification bell so you won't miss our latest videos, where knowledge is shared with passion and inspiration. The journey to explore the vast universe is far from over, and we'd love for you to join us on that adventure.